Hello guys, welcome to this new video. This one is a requested question from paper 22 of May, June 2015 of AdMath. Okay, so let's see what is the question here. So the diagram shows a cuboid of height h. As you can see, the height is h inside of a right pyramid OPQRST. That's a right pyramid. So what does this mean? It means that the base is a square. That's what it means. Okay, now the height is 8, as you can see, 8 units high with a square base of 4 units, so 4 4 4 4. Okay, now the base of the cuboid sits on the square base of PQRST of the pyramid. So the base is here of the cuboid. So if this is the base, this is also the same thing, right? The base is a square. This also will be a square, which means that all the sides have to be the same with a height of h. So you know this for now. Now this is this, and this is important here. It says the pyramid QRS, and this one are similar. So basically, the big pyramid and the small pyramid are similar. Okay, so we have to use this thing to find our answer for part 1. So first is find an expression for AD in terms of h, hence show that the volume of the cuboid is equal to this. So let me just ask you, how do you find volume of a cuboid? So you would say volume of a cuboid is the length times the width and times the height, right? That's the volume of a cuboid. But first we have to find AD in terms of h. So now where's AD? AD is this one. We have to express this in terms of h. So we have to use this information that these two are similar. Basically, the small pyramid and the big pyramid are similar, so we have to use that information. So this side is corresponding to this side, so this are corresponding sides, so we can form an equation. So we can say AD for the small pyramid over this side is 4 for the big pyramid needs to be equal to, the height is for the small one is what? This is h, this will be, so the height of the small pyramid will be what? This is h, this is 8, that has to be 8 minus h. So the height of the small pyramid will be 8 minus h. Now what is the height of the big one? It is 8. So this will be your equation that you have formed for AD. Now let's solve this to express AD in terms of h. So right now we have AD over 4 is equal to 8 minus h over 8. So we can do this because it is given that these two are similar. The corresponding sides are proportional to each other. That's what it means. Now let's simplify. So divide by 4, that will be 2. So AD is equal to 4 minus h over 2. That is for the first part, AD in terms of h. Now, to find the volume of the cuboid, as you can see, cuboid has a base of square and a height of h. So this is AD. This is also the same. So this times height will give you the volume. So volume, the length is AD, so 4 minus h over 2. The width is also AD because it is a square, right? And times the height h. Now let's simplify, so that will give you 16, and then that will be minus 2h, right? 4, so sorry, this time this, yep, 2h. Then we have minus 2h plus h squared over 4 times h. Now simplify, that should give you 16 minus 4h plus h squared over 4 times h, and that should give you 16h minus 4h squared plus h cubed over 4. So let's rearrange. Volume V is equal to h cubed over 4 minus 4h squared plus 16h units cube. This is shown as required. So to find this, the most important part is to understand this, which is using similarity. So similar means we can compare the corresponding sides. For example, what is the corresponding side of this one? You would say it will be this one, right? So same way, this was corresponding to this one. So we write AD over 4 is equal to, height is, small one is 8 minus h, so 8 minus h divided by the big one, which is 8. So this is how we form an equation for AD and then solve to find the volume in terms of h. That is the first part. Now for part 2, given that h can vary, find the value of h for which we have v is a maximum, right? So we know that v is equal to h cubed over 4 minus 4h squared plus 16h. So to find the value of v, h at a maximum. So as you know, at max value, we know what? We know that dv by dh has to be 0. So let's find dv by dh. So dv by dh is equal to 3h over 4 minus 8h plus 16 is equal to 0. Next step is to eliminate this 4. We have to multiply by 4 everywhere. You will get 3h. So that was h squared. Square minus 32h plus 64 is equal to 0. So now we have to factorize this. Two brackets. 3h times h. 64 is 8 times 8. To get minus 32 has to be minus 24 minus 8. So here we have two values of h. H is equal to 8 over 3. H is equal to 8. Now we have to choose for which one we get the maximum value. So to find max or minimum value, we have to find d2v by dh2. That should give you what? Let's see. You will have 6h over 4 minus 8. Now let's test this. So let's simplify. That will be 3h over 2 minus 8. Sorry. That will be this second derivative. Now we have to test at h equal to 8 over 3. What is this value? Replace. You will have 3 over 2 times h minus 8. That is 4 minus 8 will be minus 4. It is a negative value. So we say when d2v by dh2 is negative, v has a max value at h equal to this value. Okay, that will be your answer. Now you can also test this one to see what happens, right? So let's say d2v and dh2 when the value of h is equal to 8. So replace, you will have 3 times 8 divided by 2 minus 8. That should be 12 minus 8. That will be minus 4. Sorry, plus 4. If the value is positive, it means that it is a minimum value. So this will not be the correct value for h. H will be this value. Okay, so that will be this question number 11. If you guys have any other questions, let me know down in the comments. I'll get back to you as soon as possible. As always, thank you for watching. I will see you soon.